This is activity 4, which are not proportional, from lesson 10, introducing graphs of proportional relationships. And in this activity, you're given 4 graphs, and you're asked which of these 4 graphs cannot be proportional relationships. And you're supposed to explain how you know that. Well, first of all, in looking for a relationship that is proportional, you're going to look for a straight line, and you're going to look for that line to go through the origin, so to go through 0, 0. So 2 things for a relationship to have to be proportional. Straight line, and it goes through the origin. You can also look to see if you increase x by a certain factor, if y increases by that same factor. So if you double x, does y double? If you triple x, does y triple? 4 times x, is it 4 times y? So first of all, let's look at a couple of these graphs that look to be proportional based on the beginning part. Now, first of all, I'm going to change, I'm going to add to the x-axis these fourths. For some reason, they marked this as 5 units and then divided this into 4 equal parts. So that means that this first part is 5 fourths, then it's 10 fourths, 15 fourths, and 20 fourths, which is 20 divided by 4 is 5. And I did the same thing down here because I want to take a look at doubling along the x-axis, or 3 times or 4 times. So it's easier if I do that in fourths. All right, so the 2 graphs that are straight lines, actually there's 3 graphs that are straight lines, but the 2 graphs that are straight lines and go through the origin, it looks like those probably represent proportional relationships. So then you can check if you double the value of x. So you go from 2 to 4. So at 2, it's 10. Y is equal to 10. At 4, y is equal to 20. So that makes sense. If you double the value of x, 2 to 4, the value of y doubles from 10 to 20. So that looks pretty good. And down here for D, it's a straight line that goes to the origin. If you double x from 5 to 10, so at 5, x is 2.5. I'm sorry, y is 2.5 for x equals 5, and when x equals 10, y is equal to 5. So that looks good. If you double the value of x from 5 to 10, then you double the value of y from 2.5 to 5. Now you can say that these relationships look to be proportional within the region graphed, but you don't know for the entire relationship if it is proportional, because you don't know what happens outside the graph. If they gave you the equation, then you could say for sure, yeah, that relationship is proportional because that equation would apply to every point on the graph, even outside what's shown in these graphs. So it looks like they are proportional, but the relationships that you can definitely say are not proportional are the relationships that do not go through the origin, straight line, but it doesn't go through the origin, and also a curved line. So let's look at those 2 for a second. So the answer to the question is really going to be B and C. So B is a straight line, but it does not go through the origin. So just to check, what happens when you double the x value? What happens to the y value? Well, if you go from 5 fourths to 10 fourths, that's doubling from 5 to 10. So at 5 fourths, y is equal to 10. At 10 fourths, y is equal to 15. So y does not double. Y goes from 10 to 15 rather than 10 to 20. So it's another piece of information that tells you that B is not a proportional relationship. And C is a curve, so that's definitely not proportional. And let's just take a look at what happens if you double x. If you go from 2 to 4, what happens to y? Well, y is 10 when x is 2, and y is 20, 30, it looks like about 32.5, maybe 32 when x is 4. So y is much greater than 20. So if it doubled, it would go to 20. It would go from 10 to 20. But it actually goes from 10 to something greater than 30, something between 30 and 35, maybe about 32. So another piece of information that tells you that this is definitely not a proportional relationship, but you knew that anyway because it's a curve. All right, so the answers are B and C.